this video, I will show you the most easiest and the most generic technique to integrate a functions of type which are linear in sine and cos in the numerator as well as in the denominator. By using this technique, you can literally integrate any function of such type. You will see how beautiful that technique is in a second. Whenever you want to integrate a sin x plus b cos x divided by c sin x plus d cos x, in other words, which are linear in sine and cos in the numerator as well as in the denominator with different coefficients a, b, c, and d. You have to do just one thing. Try to express numerator as a into denominator plus b into derivative of the denominator. Okay, we'll see how do we do that. But remember that we can express whenever we see a linear function in the numerator and denominator of sine and cos. The only thing that you have to do is express numerator as a into denominator plus b into derivative of denominator. Let's substitute the values of the numerator and denominator. So the numerator is sin x. So basically, we have to express sin x as a into denominator. Denominator is sin x plus cos x plus b into derivative of the denominator. The derivative of denominator is the differentiation of sin x is nothing but cos x, and the differentiation of cos x is minus sin x. I hope that makes sense. So basically, we have to express sin x in the form a into denominator plus b into derivative of the denominator. Now, once you find the values of a and b, your problem really becomes a cakewalk. Let's see how do we find the values of a and b. In order to find the values of a and b, you have to compare the coefficients of sin x and cos x on both the sides. So on left hand side, the coefficient of sin x is 1. So we have 1 is equal to. On the right hand side, the coefficient of sin x is, here you have a, and coefficient of sin x here is minus b. So you have on the right hand side, coefficient of sin x is a minus b. Now let's see what's the coefficient of cos x on both the sides. Coefficient of cos x on the left hand side is 0. Okay. On right hand side, the coefficient of cos x is a, and over here it is b. So a plus b. So basically you have a plus b is equal to 0 and a minus b is equal to 1. Once you solve these linear equations and find the values of a and b, it becomes very easy to solve that integral. So therefore, when you have a plus b is equal to 0, you can just say that a is equal to minus b, and we can plug in that value in this equation. So instead of a, we can just write minus b. So we have minus b minus b. So therefore, we have minus 2b is equal to 1, which means that b is minus half. And if you know b is minus half, if you plug in b over here, you get a is equal to plus half. Very easy. Now what you can do is you can substitute the values of a and b that you found in this equation, original equation that you wrote. So therefore, we can say that sin x is equal to a into sin x plus cos x. So a was half, so half into sin x plus cos x plus b into, b is minus half, so minus half into cos x minus sin x. So we were able to express the numerator as a into denominator plus b into derivative of the denominator. Now the only thing we have to do is substitute that value in the numerator. So we found the value of sin x over here. We can just substitute that value over here. So our integral will become, the numerator is sin x. So in the numerator, we can just write half sin x plus cos x minus half cos x minus sin. In the denominator, we already have sin x plus cos x. So we have sin x plus cos x, and we are integrating with respect to x. Now you can split that function. So we can split this and give it to both of these terms in the numerator. So we have half sin x plus cos x divided by sin x plus cos x with respect to x. We'll write that with respect to x in the end, minus we have half cos x minus sin x divide by sin x plus cos x, and we are integrating, remember, with respect to x over here. Now you can give that integral to both of those terms. This will get cancelled first of all. So at this point, you can factor out half and split that integral in both of those terms. So you'll have first integral will be integral of 1 with respect to x, because once you factor out half, you'll be left with 1 minus, you already factored out half, so you'll be left with integral of cos x minus sin x divided by sin x plus cos x with respect to x. I hope that makes sense. Now, if you notice carefully, the differentiation of this function is nothing but the numerator. That's how we have set this up. So differentiation of sin x is cos x, differentiation of cos x is minus sin x. So what you can see here is this integral is nothing but of the form f dash x divided by f of x with respect to x. Whenever you see f dash x divided by fx, the integral of this is standard. It is ln of f of x. Okay. Remember, when the derivative is in the numerator and the function is in the denominator, the integral of such function is nothing but ln of fx. So what you can do is just write this as half integral of 1 with respect to x is nothing but x minus, and this can just be written as ln of f of x, ln of sin x plus cos x. Okay, let's close the bracket at the constant of integration c, and this is nothing but the final result of the integral that we are looking for. If you want to learn about more such tricks, don't forget to like this video and subscribe to this channel. I do post math and calculus content every single day. That's another reason to subscribe. I'll see you tomorrow.